Okay, cool. I have a very low turnaround and it's been 15 minutes. Guys, please join within the first 10 minutes so we can start the class on time, right? And it's a 2 hour 30 minutes class. So let's quickly be considerate of the time. Okay. Anyways, let's quickly revise what you have done till the last class and then we are going to go for the next part. So until now, we have done our 9 case studies. This one is the 10th case study that we are doing, which is the final case studies, which is designing WhatsApp, Messenger, or any chat application, real-time chat application. Post that, we are going to start from our low-level design. We have got 3 classes for our low-level design. There we are going to discuss about design architectures and some use case studies. In addition to that, we are going to cover the activity diagram, use case diagram, which are all covered under LLD. Okay, so we have 3 classes for that starting from tomorrow. Today, we have to just cover WhatsApp and any of the questions if we have related to high-level design, if we got enough time for that. But anyways, first we have to complete our high-level design for WhatsApp, Messenger, or chat application. Coming to the last class, what we were covering? We're covering our last system level design, high-level design, which was designing a taxi sharing service, which is Uber, Grab, or Ola. We talked about the use case, how does it work, or how does it different from the Yelp or Just Style or a Suleka use case, where we had a static location, right? So this is a dynamic location, and that's where exactly the difference comes in, where we have to make a difference between the two system levels. Okay. Now I talk about how does the request ID use case work. But before that, let me open the 10th June class also. So it becomes very easy to revise the entire thing. All right. So we had this 10th June. This was the Uber system design that we're talking about. We talked about the use case, requirement clarification, capability estimation constraint, basic level design algorithms, right? That will remain the same exactly that we have in the case of Just Dial as well. Okay, Just Dial or Yelp, whatever you call. We talked about the sequence location. SQL location is not optimized. We talked about the grid-based location, which definitely includes some optimization because I can find the nearby places very quickly. But again, the use case comes that if for uneven storage, that is not going to be a good idea. How I can further improve it? I need to further subgrid to location. And that is where we come with the idea of dynamic size grids or quad-tree-based approach. Quad-tree is a data structure, which is based upon a tree, which you keep on dividing upon four number of children, depending upon how many different places you want to store in a grid. Okay. Data structure, we talked about limit, we talked about this is called quad-tree. How we build that quad-tree, how we populate that, all of that things we discussed, right? Now the major difference comes. This is exactly same as the Yelp till this part. Now the major things come is that when we made quad-tree, to find very static nearby drivers, right? So whenever I have to read something for my read operation, they are very, very efficient. But are they efficient in the right operation? No. While I was building the quad-tree, my indication was that I have to read something very quickly. If I want to find nearby locations, nearby places, nearby petrol pumps, all of these cafes or any restaurants, that is what I have to do. So many read calls will be there, not too many write calls will be there. But in the case of where I'm making a taxi sharing service, my application or my location will be changing every 3 seconds. The driver will be reporting after every 3 seconds. So can my quad-tree is sufficient enough to handle such a fast update? If not, what is going to be the solution? So there we talked about, do we need to modify our quad-tree first? That is the first question which comes. Do we need to modify our quad-tree every time a driver reports their location? So first of all, driver is reporting after every 3 seconds. And then you multiply with the number of drivers. We have 5 million drivers, and every 3 seconds, just count the number of events you'll be getting every day. Now, there are two scenarios. What happens if we do it and what happens if we don't do it? If we do it, then I have to update my quad-tree for every change in driver's location. That is going to definitely consume a lot of time and the system resources, right? And if I have to update the driver to a new location, I have to find the new grid based upon the previous location. So the improvement is going to be from the previous grid, I have to update to the new grid. So from the previous grid, I have to delete it, and the new grid, I have to add it. Okay. And once it is very possible that after this move, if the grid location reaches the maximum limit of drivers, which we have kept as 500, then again, I need to repartition it. So too many things needs to go if I'm doing a write operation. Second thing comes, what if I don't do it? If I don't do it, then in that case, if I don't with every update from the driver, then there will be stale data. Stale data means old data, and it will not reflect the current location of the driver correctly. Now, the major purpose of building my quad-tree to find the nearby places efficiently, not for the right calls. Now the question comes, all active drivers are reporting their location after every 3 seconds. So it's going to be a lot more updates happening to quad-tree rather than the query time. Okay. Because not in every 3 seconds somebody is requesting a ride, but in every 3 seconds all drivers are reporting their location. So that is going to be more write calls as compared to the read calls. Now what we have to do? If I do it, then there's a problem. If I don't do it, then also there's a problem. So we need to find a middle ground. So what is the middle ground here? Of course, we need to find the latest position, which is reported by drivers after 3 seconds. But do I need to immediately update in the quad-tree? No. Instead of immediately updating in the quad tree, I can use a hash table and I can keep that exact location in the hash table. Why? Write operation and read operation in a hash table is big of fun. That's a very basic data structure algorithm, but this is something which is always used in the system design. Very basic algorithms. So your hash table, we can have a lookup in O1 time, we can have a insert in O1 time, and we can have as many big hash table as we want, right? Now that I don't need to update quad tree, I can update in the quad tree later, but my source of truth will become the hash table. So what will happen is, let's assume that driver's location will be reflected in quad tree within 10 seconds. So driver is updating after every 3 seconds, but in my quad tree, it is reflected within 10 seconds. What do I gain of this 7 seconds? The gain of this 7 seconds is, in that meanwhile, my hash table will store the current location reported by the driver. So let's name that hash table or a hash map as a driver location hash table. So what does the flow look like? Driver is reporting after every 3 seconds, but that is not directly returned to the quad tree. That is first returned to the hash table, which is the source of truth for driver location. And then it goes to the quad tree, which is updated after every 10 seconds. And that quad tree acts as a source of truth for my client. That is why when a driver end is updating after every 3 seconds, but as a customer end, you are seeing the location of driver. You're not seeing the location in every second. You're seeing after every 10 seconds. So the driver might, that is the reason if you might have sometime noticed, sometimes Uber shows the driver is going to arrive in 1 minute or 30. I don't think they show 30 seconds. I think they show only in minutes. I've not used that much Uber, but if you guys have used it, you will definitely notice they don't show in seconds as per my understanding. They show in minutes, right? So 1 minute, 2 minutes, or arriving, so something like that. But even though it is showing 1 minute, the driver just arrives, right? How is that? Because it is not updating after every second, it is updating after every 10 seconds. So 10 seconds before it was updating a minute, but within 10 seconds, the driver has covered the distance and the driver is in front of you. So the source of truth for a client or basically a customer, let's put it a customer, is this quad tree, which is updating after every 10 seconds. So the location that you're seeing on front of you, that is updating after every 10 seconds. But the actual driver who is driving, they're updating after every 3 seconds. Okay. Now the question comes around it, how much memory we are going to need it. The memory we're going to need is, I need to store my driver ID, the present and old locations. So driver ID is going to be 3 bytes. Why did I kept 3 bytes? 3 bytes means 24 bits. 2 raised to the power 24 can store millions of drivers. You want to keep out 4 billion. 2 billion means 25% population of Earth will become Uber driver. That is not correct, right? 25% population of Earth are not Uber drivers. So we don't need the case where I have to store the 2 billion Uber drivers. It might be possible, maybe 50, 60 years later, but for our use case, we don't need it. So 3 bytes is sufficient enough. Latitude 8 bytes, longitude 8 bytes, latitude 8 bytes, longitude 8 bytes, old and new, right? So total that becomes what? 32 this and plus 3, 35 bytes. 35 bytes, I need it for one record. Total drivers, 10 million. Total size required for all drivers, 10 million into 35 bytes, which become 350 MB, which is not that large. 350 MB is currently definitely not that large for our databases or any kind of servers for that matter. Now, how much bandwidth our service will consume to request the location from all drivers? So I need the driver ID and their current location. So 3 plus 16 becomes 19 bytes. After every 3 seconds from 5 million daily active users, 19 bytes into 5 million, 95 megabytes per 3 seconds. And if I calculate, so 95 by 3 roughly comes around 32 megabytes per second. This is the bandwidth I need, okay, just to keep an update on my hash table. Then the question comes, do I need to partition or distribute my hash table onto multiple servers? The very first thing of partitioning is, why do we do for partition? First, when the site becomes very large or something, if you need to, if you're having too much of read calls, that is only on one server, that is very distributed. These are the two major reasons whenever you partition anything, be it a hash table, be it a hash map, or whatever database it is. In our case, my memory is just 350 MB, no doubt about it. My bandwidth requirement is 32 megabytes per second, not that large again. If I just consider based upon memory and bandwidth requirements, I don't need partitioning. This is something which I can easily store in one server. I don't need multiple servers to hold this information. That is correct. But if I talk about my read calls, which are happening all the time, one server will become very costly. Why? Because after every 3 seconds, you're going to have these calls. So for fault tolerance, performance, and scalability, performance is the major reason. We should definitely distribute onto multiple servers. Now, whenever the term comes that I'm going to distribute it or I'm going to partition it, the first question is, what is going to be the partitioning ID? Means, what is going to be the factor on the basis of which you're going to divide into multiple servers? Now, partitioning ID should be the driver ID so that I can have a uniform partitioning. Why? What do we have here? We have a driver ID, we have old location, and we have new location. That's it. We have only 3 things. If you keep old location, in one location, there can be multiple drivers. So it will create uneven partitioning. Again, you need to partition. So it doesn't make any sense. In the case of new location, in new location, again, it can happen the same thing. Only driver ID is the one partitioning ID which will have a uniform partitioning. Why? Because in every driver ID, you're just going to have the location, latitude and longitude. So it's going to be same for everybody, right? Any driver in the world. So let's call this partition server as driver location server. So let's say I have one particular server. Now I divide into 10 servers. So my hash table is distributed across 10 different partition servers, which I'm calling as driver location server. Let me highlight this term also, driver location server. Okay. Now, what are these driver location servers storing? Apart from storing the driver's location, each of them are storing two things as well. Is that as soon as the server receives an update from our driver's location, which is after every 3 seconds, they will broadcast to all the interested customers. Now, there are two terms here. What do you mean by broadcast and what do you mean by interested customers? Broadcast means communicating to everybody in the queue. I'm talking about the queue because broadcast means more than one particular receiver. So you're going to message everyone in the queue. Now, what do you mean by interested customers? Interested customers means customers in that area who are looking for a ride at the moment, right? So as soon as you see there is an update for a driver's location, you are going to broadcast to all the interested customers. Second, the server needs to notify the respective query service that we have to do to refresh driver's location. So remove from the previous grid, add to the new grid. This happens in every 10 seconds. So these two things, these DSP will be doing, which is driver location service. Now the question comes, how can we efficiently broadcast the driver's location to all interested customers? So here we are going to have a push model where the server will push the locations to all the relevant users or client. So for that, I can have my dedicated notification service, which will broadcast the current location of drivers to all the interested customers. How do we do that? This is built upon the PubSub model, which is publisher subscriber model. Here I talked a bit about publisher subscriber model and compared it with the producer consumer. Producer consumer, I believe everybody should know about, but I covered in a bit brief. Producer means produces the events, consumer which consumes the events. There are no event channels in between, direct events are sent from it. In a PubSub model or a publisher subscriber model, what do? It's an enhanced version of producer consumer architecture. The difference is that we use specific channels or messaging queues from publisher to subscriber. And these channels can be multiple also. So you can have one list of publisher, you can have multiple list of subscribers, and for each list of subscribers, you can have different channels. For example, the best idea that I can give you is that think of Netflix as an example, right? So every user prefers to have a different category of recommendations. So think of like different category of users. I'm talking about somebody who likes to watch comedy, somebody who likes to watch horror and those things. And you are catering to different channel messages. So those channels I'm giving, for example. So these are events and messages and they go through different channels. And that is the difference between a PubSub and a producer consumer model. How does that comes into picture for our use case? When a customer will open the Uber app on their mobile device and they look for a ride, the first thing is they're going to query the server to find the nearby drivers. On the server side, what is happening? Before returning the list of drivers to the customer, before returning the list of drivers to the customer, all the customer who are looking for an update will subscribe for the update for drivers, right? At a server end, we are maintaining a list of interested customers, which I'm calling as subscribers because we need to broadcast to them. They are interested in knowing the location of a driver, and whenever they make an update, we'll broadcast in the current location to the all subscribed customers. So two kind of customers will be updated. First, if you booked an app and if a driver accepted, definitely you'll be receiving the notification. Part number one. Part number two, while you are booking the app, what does Uber does? Uber just gives your request to the top 3 nearest drivers, right? It can be nearest, it can be based upon rating, it can be multiple factors. Let's say 10 drivers are there exactly at the same location. So it will send to the top 3. Out of these top 3, if any one of you accept, you will be connected, you will be receiving their live updates with the flow we just discussed. And if none of them accepted, it will go to the next 3, then next 3, the next 3, and so on and so forth. So during the time duration when Uber is sending that request to all the 10 drivers nearby or the top 3 drivers nearby, in that case, they will need to be updated with the location of those drivers. That is how Uber finds what is the nearest driver near you, right? So two categories of subscribed customers will be there. And this is how we make sure that our system always show the driver's current location to the customer. Okay. Both categories of subscribed customers. Then we talked about how much memory we'll need to store all this subscription. So let's do some calculation. My daily active customers are 250 million. My daily active drivers are 5 million. So on an average, if 5 customers subscribe to one driver, which is fine because in one location, one customer can be connected. 4 other customers will be looking for a ride. So I need to store my customer ID. I need to store my driver ID. So 5 million into 3 plus 5 million into 5 into 8. That gives me about 5 million into 43 bytes, which is 210 MB, which is fine. Again, not a very large space. Bandwidth requirement, total number of subscribers will become 5 times, so 25 million. 25 million multiplied by again 19 bytes, 48 megabits per second. This 48 megabytes per second, not bits per second. 48 megabytes per second, that is a huge bandwidth requirement, but that is fine. We need to update to all the subscribers, so 48 megabytes per second is the bandwidth we'll need. Then the question comes, which is going to be the effective communication protocol? It is going to be HTTP long polling or server-side event. So either we can send the server-side event or we can go for the long polling, where all the customers will be requesting for the drivers update after every few seconds. Then the question comes is pull model, which is how clients will going to pull the information about nearby drivers from the server. So clients send their current location and server will find the nearby drivers from the query and then to the client, right? Then the client will update their screen to reflect the current position of the drivers client query after every 5 seconds to limit the round trips to server. So both models are being used, pull model and a push model. Push model, location of drivers while they're in trip or after confirming a trip, that is when you're tracking the location, where it is sent from the server side events. Pull model, where a client is requesting for it, that is to find for the nearby drivers when you're looking for a ride. So nearby drivers / looking for a ride. That you can do. Then we talked about detailed component diagram and so on and so forth. And then we moved to our last class, where we talked about how does the request add use case works. Request add use case work, the customer will first put a request for the ride. Then we have one of the aggregator server, they will take the request and will ask the query for nearby drivers. That is the purpose of query, to be very precise. Then the aggregator server will collect all the results, sort them by the ratings, will send notification to top 3 drivers. Whoever accepts first will be assigned the ride. This is the other drivers will update a cancellation message. If none of the top 3 drivers accepts or respond, then it will just thank for the next 3 drivers from the list, and so on and so forth. Once a driver accepts a request, then the customer is notified and you can see their live location. And application, what if a driver location server or notification server dies? What do we do in the case of fault tolerance? The very first thing is that we have already partitioned it, right? So even in this partitioning, we would need replicas of those servers if my primary, which is my master dies, secondary slave can control, right? We can store this data on some persistent storage like SSDs. Why did I talk about SSD? Because they provide much fast IO as compared to just normal database, right? Or reading from a cloud database, to be very precise. This will ensure if both primary and secondary server dies, we can still recover from the persistent storage. Why? That hash table that you're storing is actually the core of entire Uber. So if you're storing in SSD, even if your primary and secondary server, which are hosted somewhere else, even if both of them dies, you can still persist it from the SSD, right? Because it's a hard device. So you can anyways have that location back. And that is the actual core of Uber or any of the delivery systems, to be very precise. Then question comes about ranking, is that how do we need to rank drivers? We need to rank drivers is depending upon proximity as well as popularity and relevance. So when we return the top drivers from a given radius, what do? We keep the ratings of overall ratings in one database and query, right? So we keep up, when I say overall rating, I'm not just talking about the star rating. I'm talking in terms of customer behavior and whatever factors they have. Based upon that overall rating, we also check for the proximity and then we give the return. So aggregated number can represent popularity in the system, which is called where ratings. So while searching for top 10 drivers within a given radius, we can ask each partition of the query to run top 10 drivers within the maximum radius. Then we'll find the top 10 among the list. Why? Because my query is storing the current location. So based upon the query, I'll go to the node ID and find the top drivers within that node ID with maximum ratings that I can sort with the maximum ratings. And then whatever the result I've got, I will just list it and send the notification to them. Cache part will remain the same, which cache, size of cache, which cache eviction policy, and handle the cache invalidation. All of them will remain exactly the same, right? 80-20 rule and nothing, and it will not change at all. Then we talked about the load balancer. So where do we put the load balancer? 3 different places. Client and application server, DB server, application server, and cache server. Which policy to use? Round robin is good if you're not using predictive analysis, but all of our model solutions, all of our load balancers, they come up with predictive analysis. So you don't have to worry about round robin. Okay. Finally, we started with our case number now 10, which is designing WhatsApp, Messenger, Telegram, or any of the real-time chat application services. The idea for today's class or the plan for today's class is that we are going to finish it. We are going to discuss everything in detail, including the asset service, last sync service, group messaging service, and everything. And of course, analytics and events, which are very, very major part of your WhatsApp or any of the chat application. That we're going to finish today, and tomorrow we're going to start with our low-level design. If we get time, we can definitely take up some questions or any doubts that you have, or if not, then we can arrange a doubt clearing session for HLD or LLD, whatever. But anyways, let's start with our case study number 10, whatever we've completed so far, and finish it. So the very first thing is, I asked you what is the difference between Facebook Messenger and WhatsApp. And this is very important to understand in the beginning while you're designing the system. You cannot just design a system and later tweak it. It will completely change the flow. The system will not be good at all. So understand the real life difference between, or understand the difference between what kind of system you're designing. Messenger is very different from the WhatsApp. Yes, there are many commonalities. For example, there are chat applications, both have last seen service, both have reader states, both have audio video calls, both have group chats. I agree to that. We'll not be covering any payment system as per our current syllabus, no, because we are running short on time. If we get time, definitely we can include one more class. And if we finish low-level design first, then we can include any of the payment systems. Stock market system, payment system, whatever way it works. Okay. Then we talked about these are the common parts between FB Messenger and WhatsApp. On the customer end, I asked you what is the major fundamental difference? The major fundamental difference is, does my messenger keep such backup of chat? The answer is yes, it does. How do I know? If I go to FB Messenger, I uninstall it and I reinstall it. I will find all of my chats as it is. Not even a single chat will be deleted. Not even a single message will be deleted, right? Means chats are somewhere stored at the Facebook database end, right? Wherever it is stored somewhere, because when you uninstall it and reinstall it, the chats were recovered as it is. You didn't take any backup. Reminding you again, when you're taking up FB Messenger, you didn't take any backup. You just logged in and logged out. That's it. And all your chat applications, all your chats have been saved. But in the case of a WhatsApp, there is an option called chats backup. If you don't back up your data, if you will not get any of the chats, be very clear with it. Now, backup has its own frequency, so you can go in settings and you can check whether you have done weekly or daily or whatever it is, right? So let's say you have done the WhatsApp backup data for last month. Now you do one thing, you uninstall and reinstall. The moment you uninstall and reinstall, first of all, it will ask you to recover chats from the backup. If you have a backup, it will recover from the last month, but it will not recover any of the chat between the last month till today. Okay, part number one. If you don't have any backup, then it will not recover anything. You will see the WhatsApp as you've seen it for the very first time. So all your chats are lost. If those chats were stored at the Facebook end, then this would not be the scenario. So even by some common customer behavior, you can understand. You don't need to be a developer at Facebook or a product manager at Facebook to understand how the features work. Even from a customer common sense, you can understand if they were stored at the Facebook end, I don't need to create a backup. Common sense, right? So they are definitely not stored at Facebook end. Whenever you see a WhatsApp message or whenever you write it or read it, you always see this line on the top, is that WhatsApp chats are end-to-end encrypted. What does the meaning end-to-end means? End-to-end means during the client side and during the server side, means while you are sending and while you're receiving, the message is encrypted. And when I say message, I'm talking about any kind of message, including your text, including your medias, photos, videos, whatever you're sending, locations and everything. So from the client side, it is encrypted and then it is sent through a secured channel, which is a TCP connection, three-way handshake. And on the receiver side also, that is also encrypted. So encryption happens at the client side and even on the server side, decryption happens. But it is encrypted end-to-end. That is why it is called end-to-end encryption. Okay. Then we dig deeper into our high-level design. Very first thing, what is WhatsApp? What are we designing here? It's a chat application which provides text-based instant messaging service to users. Can be accessible from mobile, website, or smartwatches. And apart from text-based, it can have media, right? Location, context, sticker, photo, video, GIS, etc., etc. Then we talked about requirement clarification. Requirement clarification are very simple in terms of function requirement and non-function requirement. First, it should support 1:1 chats. It should support group chats. It should have video, image, and file sharing capabilities. It should indicate read receipt of messages. It's a user option if they want to share, they don't want to share. That is what we're going to discuss, and we'll go to that. It should show me the last scene of users. Again, user can select to share the last scene or not share the last scene. And status story is something which we can keep, which is just one service, but okay, 24 hours, and the users can select who can see my story or who can hide it from my story, vice versa. In terms of non-function, these are the function requirements for my WhatsApp. In terms of my non-function requirements, the very first non-function requirement is it has to have very, very low latency. Why it has to have very low latency? Because you're making a real-time chat application. During the real-time chat application, you cannot afford latency. Part number one. Part number two, it should be always available. Why should be always available? Because while you are making WhatsApp or while you're making any real-time chat application, the first thing is that if you want to send something, it should be sent. Your WhatsApp should be available. It should not be down. There shouldn't be any lag, no doubt about this. It should be very highly scalable because we are building at a scale of almost 4 billion users worldwide. So it needs to be very, very scalable. There will be discussion around availability and consistency. Who will prevail in this case? Let's try to understand. If I go with strong consistency, one moment. If user is online or goes offline, how application shows this precise information. So just to give you one word answer, that is taken care by the last scene of users. Okay. It doesn't show you offline, it shows you online and the last scene. That's it. Okay. Now, coming for the strong consistency, in the strong consistency, all nodes will be updated with the most recent data at the same time. Eventual consistency, all nodes will be updated, but with some lag. I won't say lag, but yeah, few milliseconds, few microseconds delay eventually. Now, what happens in the case of consistency in WhatsApp? Let's say I have opened WhatsApp in mobile, website, and smartwatch, 3 devices A, B, and C. A, I'm going to send or receive the message. Devices B and C, they will take some time to be in sync with device A, which is fine with me. If they take some time to be in sync, that is fine. But imagine devices B and C, WhatsApp is not opening at all. That is the worst case scenario. I want my application to be available rather than I can accept some kind of delay. I can accept some kind of latency across the devices. Across the devices, that is acceptable. But in that some device, it is not opening at all. It's not even available at all. That is not acceptable. That is why written availability over consistency here. Okay. Now we talked about also one more thing I talked about is WhatsApp. It's in smartphone, yes, but is it in apart from smartphones? So first you need to understand what is a smartphone. A smartphone is something which contains certain applications which are not available in the common phones. For example, touchscreen does not make a smartphone. A lot of people confuse that touchscreen means smartphone and smartphone means touchscreen. Nothing like that. Touchscreen is another feature that you are able to navigate through the mobile screen by having a touch. That is a touchscreen. A smartphone is something which contains features apart from the basic calls of like it can have it should have certain level of Bluetooth, which is 2.4 gigahertz, which is more than that. It should have a camera. It should have certain features which are not available in a normal smartphone, apart from just calling and everything, right? That is what it makes a smartphone. So definitely, WhatsApp is there in the smartphones. It's available in App Store. It's available in Drive. All of that is there. But even in the keypad phones, there are WhatsApp. Those majority of the people don't know it, but even in the keypad phones, they have WhatsApp. Now the question comes, in keypad phones, you don't have Play Store, you don't have App Store. So how do you have WhatsApp? They have WhatsApp pre-installed in it. Okay. Yes, updates are being sent from the server end, so they don't need to go to the App Store or they don't need to go to the Play Store and update because there is no App Store or Play Store there, right? So in the keypad phones, it is already installed, just like you might think of some other applications which are already installed, like FM radio or those kind of things, right? So even in the keypad phones, they have it and they have it since 2018. Okay, not it's now in 2018. How message order is preserved in the eventual consistency? Message order has nothing to do with the eventual consistency. Okay, eventual consistency, when I talk about, I'm talking about across the devices. That is nothing to do with that is nothing to do with how the message is preserved. Message is preserved based upon the three-way handshake that we're going to discuss. What happens if message M1, M2, M3, how this ID is preserved? Just to give you one word answer, all of this communication happens via WebSockets, which used on TCP. So TCP works only after one message is acknowledged, then you will have the other message. Okay. That is based upon three-way handshake, it happens, which we're going to consider or talk about today. But just one word answer, TCP. Okay. Then we talked about capacity estimation and constraint, back of the envelope estimation. I told you about the total users, which is 3.8 billion. I'm pretty much sure they're going to touch 4 billion soon. So maybe some in next few months. Monthly active users are 2 billion and daily active users are 1 billion, right? What is going to be the total messages which we are going to send or consume in a day? Let's try to have some number. Daily active user is 1 billion. Now, on an average, each user sends 40 messages. 40 messages is nothing on WhatsApp if I talk about 24 hours. People send a lot more messages than 24 hours. On the other hand, people don't even use WhatsApp. So I'm not talking about like extreme cases. I'm talking in general. So 40 to 50 messages is very, you can take a very general example for every average user. So total number of messages become what? 40 or 50 messages multiplied by 1 billion, that gives you roughly around 40 billion messages per day. You are going to handle you're going to make a system which is going to handle 40 billion messages per day. Okay. Then we talked about storage estimation. If I talk about average size of 100 bytes per message, average size of 100 bytes per message, in 1 day storage required will be 40 billion message into 100 KB, which gives me 4 terabytes a day. If I talk about 5 years of chat history, 4 terabytes into 365 into 5 years, 7.2 petabytes. This is a very, 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 very huge number. And this, I didn't talk about any videos, photos, images, contacts, etc., which can be very large also. Okay. In addition to that, we need to store other user information, their metadata, their message ID, timestamp. I've not included compression replication in this calculation. I've done a very basic calculation. If I'm just sending a text message, 100 bytes per message, I'm going to need 4 terabytes per day. This is the kind of storage I will need. I need to store 40 billion messages per day. This is the kind of service I'm going to make. A quick question here. If WhatsApp does not store the messages, why are we doing this calculation? If WhatsApp does not store the messages, why are we doing this calculation? If messages are not stored, why we need to do this calculation? Come on, guys, be quick. Question is clear to all? Question is clear to all? Any doubt in the question? Okay, that is fine. If anybody has doubt in the question, let me just repeat the question. One moment. Yeah. Okay. Let me explain the question again, those people who don't get it. Understand this very clearly. We just talked about the basic difference is that WhatsApp does not store the chats. That is the very first thing we talked about. How do we know that? Because we have to create a backup. If we store the chats, we have to create a backup. Common sense. Now what we are doing is, in our system design, in the part 2, we are talking about how much storage it needs to store the message. Now that thing is contradictory. On first thing we said that it does not store the message. And on second thing, we're calculating how much size it will need to store the message. One of the things is incorrect, or maybe it is not incorrect, but what is the issue with that? Why do we need to calculate the size? Question is clear now to everyone. Some people don't have the question clear, so I explain it again. If you are not storing the chats, why are you calculating the memory which will be needed to store the chats? Okay. Some people has given the correct answer. Some people have not given the correct answer. That's fine. We'll get to know the answer when we deep dive into the system design part of it. Okay. Or component level design part of it, not the system design. Okay. But long story short, we are calculating the size here means we are going to need it somewhere. Okay. We're calculating the size means we are going to need it somewhere. That's why we're doing the calculation. Otherwise, why would we do it? Then we talked about the bandwidth estimation. What is the bandwidth estimation I will need? I will need 50 megabytes per second. So from my server end, I need for upload and downloading data, the bandwidth of 50 megabytes per second. So if I talk about final numbers, incoming data, outgoing data, 50 megabytes per second, 50 megabytes per second, total messages 40 billion. Storage for each day 4 TB. For 5 years, I'm going to need 7.2 petabytes. Then we finally talked about high level design. What did we talk about in high level design? I talked about the design. So I'll just show you that diagram again. There you go. This is the diagram we talked about in high level design. Very basic high level. That's why it is called high level. We have two users, user 1 and user 2. So user 1 and user 2, they're sending message A, they're receiving message B. One is sending message A to B. So one is sending message A to 2, and 2 is sending message B to A. So it's send message A, receive message B, send message B, receive message A, vice versa. There's a chat server, there's a data storage. Very basic, very high level design, right? So coming back to our class, yeah, this is the high level design that we talked about. At a high level, we need a chat server that will be the central piece, which will orchestrate all the communication between users. So when a user wants to send a message to another user, they will connect to chat server, then pass that message to other user and store in the database. This line is important. Store it in the database means messages are stored. Now the question comes, if the messages are stored in WhatsApp, why did we say that messages are not stored? And not just we say that, we prove that messages are not stored. If messages are stored in WhatsApp, if messages are stored, just do it like Messenger, log in, log out, uninstall, install, you should be able to get back again. But that's not how it works. So what is something which is hidden here? That's something hidden we are going to explore. But anyways, as of now, the detailed step-by-step workflow, which we have talked about is, user A sends a message to user B through the chat server. Okay, what happens next? Server will receive the message and send an acknowledgement to user A. The server stores the message in database and send the message to user B. Now just wait a moment. Server stores the message in the database and send the message to user B. When user B receives the message, it sends the acknowledgement to server that, hey, I have received the message. And then server notifies A that message has been delivered to user B. And something which I not told in the last class, message is deleted from the database after user A is informed. So what happens? Let me just make it in a simple design. Let's call it 1, let's call it 2, and 1 send a message. This is some database, just an example I'm talking about. Okay, let's say 1 send a message called M1. Any message, let's just say hey and I, whatever. This message is stored in the database, right? It doesn't directly go to U2 or whatever user 2. Now what happens is, this DB, or technically DB does not send the message, there's going to be one more service, but as of this moment, just consider it is going to send the message to 2. Now, until and unless 2 gives an acknowledgement that I have received this message, because there can be failures, right? For example, the message for some reason, whatever, was not given to 2, or the user 2 is offline at all. If the user 2 is offline, you cannot send off messages to offline person, right? So in that case, what will happen? It will wait till the user 2 comes online, and then it sends the message to user 2. The moment user 2 says that, hey, I have received the message, I give you acknowledgement. Acknowledgement means, well, acknowledgement is an English word, says means acknowledgement, right? Means I've given you permission that I've received the message. The moment it receives acknowledgement that I have received the message, now we are going to delete from the database. Why? Because you're not storing the messages for the users. You're just persisting it, that to temporarily. Why are you persisting temporarily? Because you have to. If you don't persist it temporarily, let's say a simple example. 1 sends a message M1 and the message is hi to U2, or let's say whatever user 2. User 2 is offline. Now you can send message, other person may or may not be offline, or even if it was online, but it went offline suddenly. So when the user 2 went offline, it sent a message M1, let's say hi, just a simple message. But since this is not online, that message will not be delivered. If that message will not be delivered, then in that case, message becomes a failure, right? Because message will never be delivered until the user 2 comes online. Till the moment user 2 comes online, that message needs to be stored somewhere, and then it needs to be delivered to you too. So that is why to store that temporarily till it is delivered to you too, and you too gives a confirmation that, hey, I have received the message, hi. Then you're going to delete from the database. You're going to update the U1 also that, hey, the message has been delivered. And that's exactly when you get a double tick. Okay. And that is how all your read receipt work. Single tick means it is sent from your end. Double tick means it's delivered to the person, whoever the concerned person you are delivering to. Blue tick means they have seen it. Obviously, user can decide whether they want to have a blue tick or they don't want to have a blue tick. That is how it works. Okay. And this is the reason that we need to store temporarily in the database, and then we need to delete it from the database. Is this part clear to all? Is this part clear to all? How long are they persisted if the user 2 is unavailable at all? Unavailable means user has uninstalled the app and they're not using it at all. In that case, it is going to be 30 days. Okay. Is this very basic things, but very important things? First thing is that, why are we storing in the database? Part number 1. Part number 2, why we are deleting from the database? Are these things very clear to all? Because we are going to have multiple discussions around it anyways. But these very basic things are clear to all, then just let me know. Everybody clear with it? Okay. If everybody clear, then I can clear this, and then we can go to next part. In detailed component level design, I told you about the very basic things. Somebody asked, I think, which kind of communication it happens. The communication happens in a TCP via WebSocket handlers. What are WebSocket handlers that we are going to discuss in today's class, and then we are going to deep down into component level design. Anyways, TCP is a reliable connection. It's a two-way connection. So TCP, it's no client and server, so anybody can send the message, part 1. So, and second is there's acknowledgement involved. What is acknowledgement? Acknowledgement is just a receipt that, hey, that I have received the message. Deletion is offline deletion immediately after message is deleted. Immediately after message is delivered. Okay. Yes, you can run batch scripts and all. That does not need to be optimized. But yes, just to give you an answer, immediately after the message delivered, it is deleted. If you one is sending multiple messages back to back YouTube, how is ordering handled? That ordering is I'm talking about the acknowledgement. Okay. How does TCP or how does the three-way handshake works is, let's say you handle three messages, M1, or let me make it a real life. Hey, hi, and that's it. Two messages, hey and hi. How do you make sure that it is delivered to hey and hi only, not hi and a, right? Or vice versa. So what will happen is this message, let's call it M1, and this message, let's call it M2. Obviously, at one time, at one timestamp, you're sending one message. Common sense, right? At one timestamp, you'll be sending one message. So let's say its timestamp will be T1 and its timestamp is going to be T2. And let's say that T2 is greater than T1, means high was sent first and high was second data because it is higher time, right? And it is lower time. Now, what is going to happen is this will go as part of one packet, it will go for acknowledgement. So here comes acknowledgement one, and this will go to acknowledgement two. Same process will be followed. It will go to WebSocket Handler, then it will from the WebSocket Handler, it will be sent to the message and so on and so forth. So this acknowledgement one, and after this acknowledgement one, only then this acknowledgement two will be sent. Repeating it again, only after this acknowledgement one, then only acknowledgement two will be sent. Okay, not the vice versa. One more thing to be clear is that a lot of times you would see, and you can even check in WhatsApp right now, try sending a big file and try sending a simple text message. So let's say you send a very big file first, right? Let's say something around 10 MB, 15 MB, 100 MB, whatever. And then you send simple a hi. So in that case, what will happen? That is the only exceptional case. Even not an exception, it's a common sense. First, I send a 100 MB video and I send it, let's say 10:30, whatever time, AM. Okay. And then I say a simple hey message at, let's say 10:30, same time, but some few milliseconds. So 10:30, let's say 20. I'm talking about seconds, and let's say after 5 seconds. What do you think? Which message will be sent first? I'm pretty much sure you guys would have tried. Which message would be sent first? Text message. All agree? All agree. Hey will be sent first. Why? If you're following the ordering should be this. So this is from your receiver end. Sorry, this is from your sender end. But from the receiver end, it's going to be exactly opposite. From the receiver end, it will become like this. Now the question comes, if you're talking about that ordering is maintained and TCP and everything, why this exception? Or even if this is an exception or not, forget about, we'll talk about whether it's an exception or not. The first question is, if you're saying that ordering is maintained, in that case, why is ordering not maintained in this case? Think about it. Anyways, I'll ask this question again once we'll go for component level design. Answer will all be disclosed when we go for component level design. But I'll be asking this question again. Okay. Anyways, this is what we discussed till the last class. We talked about because of file upload, download, and time stop load. You can keep thinking, but we'll go for detailed component. I'm pretty much sure you'll be able to answer by then. UDP is not a reliable connection. No acknowledgement is sent. That is why we don't go for UDP connection. Then we talked about WebSockets. These are reliable end-to-end connection, which are built on top of TCP connection, which anyways we are going to discuss in today's class. Somebody asked the WhatsApp basic tech stack. So the very WhatsApp basic tech stack, what WhatsApp is built upon is the entire WhatsApp code is written in Erlang. Erlang is not a very popular language. It is in many of the companies, but not major companies. It's not as popular as Java or Golang or any other things. Erlang is a functional programming language. It's not an object-oriented language. That is part number one. And there's a use case why we're using functional programming language. And in the coming time, it's going to be more functional programming language as compared to just the object-oriented language, which we have been using since 1980s. So pretty soon, Golang is going to be the next major language for the backend application, not just Node.js or Java or Python or whatever the common language is. The entire backend code is written in the hack, which is PHP. And database is what? Database, the initial database is MiniShaDB. It is again an RDBMS, but it is not a SQL database. A lot of people confuse it here. And in the interview also, I've seen a lot of senior engineers being confused. RDBMS does not necessarily needs to be a SQL database. Repeating, relational database does not necessarily need to be a SQL database. What is the meaning of relational database? Relational database means you are having a very formatted data, very structured data, and you're going to make relations across the tables. That is what relational database means. It has nothing to do whether it's going to be one moment. Golang you mentioned for WhatsApp or the entire industry trend. I'm just talking about the entire industry trend. Golang is not used in WhatsApp. Erlang is used in WhatsApp. Okay. Now, what I was talking about RDBMS is relational database means you are going to have a structured data where you're going to make relations across the tables. So let's say I have some primary key and some other keys, and across the tables, I can make relations between them. Cardinality can be 1:1, it can be 1:n, whatever cardinality, I'm not concerned. But the concept of cardinality is involved, the concept of relationship across tables is involved. That is why it is called RDBMS. What does SQL NoSQL means? SQL database means irrespective if it is RDBMS or not. Well, first of all, SQL database has to be only RDBMS. It cannot work in non-RDBMS relations. If you are able to query that database using SQL, if you're able to use that using SQL, then it is called SQL database. Not all RDBMS are SQL database. Vice versa is correct. All SQL databases are RDBMS, but not all RDBMS are going to be SQL database. So even in your RDBMS, it can be SQL database or it can be no SQL database. Okay. SQL database means you can query using SQL as a language, and here using query languages apart from NoSQL, apart from SQL. Okay. So MiniSTDB, which was the very basic tech stack which was there in the WhatsApp when Facebook acquired it in 2018. This is what was used there. Of course, there are many changes till then. And what is the current changes? What is the current use case we use? That we're going to discuss in the component level design. But till 2018, this is what WhatsApp was built upon. Okay. Message ordering is based on when the server received the message that we're going to discuss now when we go to component level. All the question will be answered. Don't worry about it. But there are some questions which I'm listing down, which you should ask as a customer, not necessarily not only to be a tech person, but as a customer. All right. This is something which we covered till last class. Now we're going to deep dive into component level design. But prior to that, give me clear if everybody clear, and then we can deep dive into component level design. Come on, guys, be quick. This is number 5. This is going to be number 6. Component level design. Okay. How WhatsApp knows whether user, we are coming to that. We're going to all components, we're going to discuss one by one. So I'm just showing you the component level design or the detailed system design. I'll close this one. Yeah, here it is. I'm going to just share my screen. Let me know if it is visible to everyone. Is my detailed component design visible to everyone? Just let me know in the chat. Okay. If you look carefully, I've defined, this complete diagram is divided into 3 major parts. So we'll go one by one. The first major part is the user service. That is what we're going to discuss at the end. It's not that relevant. Of course, it is relevant, but not that important, not that relevant. Last seen service, your analytics service, your user service, your group service. That is part number 1, which is user app, which we are going to discuss at the end. Part number 2 is what we're going to discuss in the beginning, which is how does actually communication flows from user 1 to user 2, user 2 to user 3, vice versa. What happens if somebody is offline? All of these things we're going to discuss now. That is part 2. Part 3 is the asset service. Now, what is the asset service? This when you're going to include any kind of assets, any image, any video, GIFs or anything, which database is used here, why we are using a CDN here, all of these things we talk about. As of now, I want all of you to focus on the second part, this part only. I will just reduce it, just this part. So you see U1, U2, U3, these are going to be different users, and these different users can be on different clients also. So it can be a mobile, it can be a smartwatch, it can be a web, whatever way you can think of. What next we have? Next, we have something called load balancer. The black symbol that you're seeing, these are load balancer. These are my users or customers. Here I have Websocket Handler. What are Websocket Handlers? I'm going to discuss. WebSocket Handler 1, WebSocket Handler 3. Okay. How would backend server know in which WebSocket handler is? I'm coming to everything. That's what we're going to discuss one by one, right? Then there is one more load balancer, and then I have group message handler, then I have WebSocket manager, then I have message service. Okay. My WebSocket manager sits on the top of a Redis cluster, and my message service sits on the top of a Cassandra. Okay. This is all in terms of my communication. Each and every part of it, WebSockets are not HTTP based, they are TCP based connections. That's why they are called WebSockets. Okay. We are going to discuss each component of this one by one, but this is the entire this is the entire how chat application works in WhatsApp. We're not talking about asset service or user service, we're just talking about chat application, including your group notifications. Okay. So let me clear this and let me start from the very beginning, and then we'll talk one by one to each part. What are these WebSockets? What are this group message, Redis, Cassandra? Why do we need it? Why does the communication happens? How do we know the last scene and everything? Everything we'll talk about here. Okay. So let's go to Sublime Text and let's discuss one by one. The very basic thing is that I talked it about the first thing is WebSocket handlers. So let's talk it about what is WebSocket handlers. Okay. What are my WebSocket handlers? WebSocket handler is nothing. It's just a simple lightweight server. What do I mean by lightweight server? What is the meaning of heavyweight and lightweight servers? Come on, guys, very basic question. What do you mean by lightweight versus heavyweight servers? It specifies load on server. Okay. So if a server is having high load, that will be called lightweight. If a server is having high load, it will be heavyweight. Service facing load. Anybody else? What do you understand by lightweight server or heavyweight server? Let's go with the very basic. In general, you must have heard about lightweight process or heavyweight process or any other terms. Forget about even process. Very basic terms. Lightweight, heavyweight are not new terms. You must have heard about this app is lightweight, this app is heavyweight. What do you understand by lightweight, heavyweight? Server with bare minimum services. Okay, what else? Well, when it comes to connection, either it's a lightweight or a heavyweight. All of them are going to support same number of connections. So connection does not make difference. Okay, enough time, guys. Very precisely speaking, the last statement somebody has given is correct. Server with bare minimum services, right? Let's try to understand. Bare minimum again is a very complex term to understand or simplify here, but just to simply put, a lightweight server means what? A lightweight server means it does not contain any logic. Any kind of business logic, any kind of data layer logic is not stored at the server end. That's what you mean by lightweight server. That is a crystal clear technical definition. No logic. Logic can be business logic or data logic. So that I'm not justifying. Resides at the server. Okay. And pretty much it contains almost no data storage. You're not storing anything. That is part number one. It is just used for communication means server means what? You make a request, server responds it. That's it. It's not storing anything, no persisting anything, no storage or persistence. What do you mean by heavyweight server on the other end? Heavyweight server means there is logic, might be business, might be data, or might be both. It resides at the server, part number one. Part number two, it definitely has data storage and persistence. It definitely has that. Okay. Now, what are my WebSocket handlers? My WebSocket handlers are, I'm just going to use WSH in short for WebSocket handlers rather than writing it all the time. My WebSocket handler is just a lightweight server. is just a lightweight server. What does it mean? No logic is kept there, not much storage is kept there. So you make a request, it will respond to it. That's it. Okay, it's a lightweight server. Part number two, each machine, irrespective whether it's a lightweight or a heavyweight, it has 65,000 ports that I have told multiple times. Okay. Imagining out of these 65,000 ports, assuming 5K ports for internal communication. Different protocols they might use for internal communication. That does not need to be TCP. Okay. Then we're left with 60K ports, right? So each device will have 60K ports. Now, 60K ports are ready to be used by one WSH. Means what? My one WebSocket handler can cater to 60,000 active users. So 60,000 active users can be connected to one WebSocket handlers. So total WebSocket handlers required will be what? Whatever total active users divided by 60,000. That's it. Whatever number you can think in terms of total active users, you can talk it about a day. You can talk it about in terms of a month, but usually let's talk about in a day. So in a day, if I have 1 billion, you divide 1 billion by 60,000. That is the total number of active users I'm going to need. Okay. These active users will require this. And one more thing to add here is these WebSocket handlers, of course, they're not going to be in one place, will be distributed across different geolocations. Why? To reduce latency. That's it. Point number one, point number two, point number three, and point number four. That's about the WebSocket handlers. So part number one, what do you mean by WebSocket handler? WebSocket handler is just a lightweight server. Explain the difference between lightweight and heavyweight server. It is just a lightweight server which is storing the connection with active users. That's it. So which user is connected to which WebSocket handler, that is also information we need to store somewhere. But coming apart from that, WebSocket handler is just connecting an active user. Means if you open WhatsApp and you're connected to WhatsApp, means you are connected to some WebSocket handler. Now, which WebSocket handler depends on your geolocation. So that depends. And of course, it can change also. For example, in one WebSocket handler, you are not able to get that much good communication. So it will switch to some other WebSocket handler. Or let's say one WebSocket handler server goes down, then it will connect to some other WebSocket handlers. So you will always be connected with a WebSocket handler whenever you turn on your mobile data and open the WhatsApp app. Okay. Technical speaking, whenever you open the mobile data, not just open the WhatsApp app, because WhatsApp is usually running in the background, right? So of course it requires permissions. I'm just talking about the basic use case. The moment you open a WhatsApp app and you're connected to a active network, mobile data, Wi-Fi, whatever it is, in that case, you will always be connected to a WebSocket handlers. And these WebSocket handlers connect 60,000 active users from one manager. So not manager, one WebSocket handler. So total WebSocket handler, total lightweight servers I will need, I can divide by 60,000. Is this part clear to all? Is this part clear to all? One guys, be quick. This basic thing clear to all, WebSocket handlers. Okay. Now I'll go back to my detailed design. I'll explain it here again. Okay. How is connection done when we start WhatsApp and a request is sent? Yes, from your client side, request is sent. Your client side means your mobile, your app, your laptop app or whatever you're using, or even your some of the smartwatches. That makes a request to the server. That happens with every device. That happens with every kind of app, not just WhatsApp. Let's say you open Instagram. When you open Instagram, what happens? Your client side from Instagram connects with the Instagram server, and that is how you're able to see feed. You're able to see your messages. You're able to see anything else in the Instagram, right? Same happens in the Facebook. Same happens in anything else. Even in your mobile banking app. What happens here? You connect and that's connect with the server. So client connects with the server. Always a request is being sent from the client to the server whenever you open any app. either running in the background or not running in the background, doesn't matter. WebSocket also works on request and response. Yes, these are TCP connections. That's it. WebSocket, okay, understand this. A TCP connection request and a response. That is what WebSocket is. WebSocket is just a lightweight server. You make a request, it gets a response. So client side, a connection request is made. One moment. Client side, a connection request is made. WebSocket handler connects with it. That's it. Nothing else. Either a successful connection or a failure connection. That's it. The receipt is connected to. That's what we are coming to next. Okay. WebSocket handler will know only which user it is connected to, but which WebSocket handlers are connected to which users, that is going to be stored in something else that we are going to come here. Anyways, coming back to this, observe something. This U1 is connected to WebSocket handler 1. Why? Because U1 is online. Okay. This U2 is connected to WebSocket handler 2. Why? Because this user 2 is also online. This U3, you don't see any connection with any WebSocket handler. Agree? U1, there's a connection with WSH1. U2, there's a connection with WSH2. U3, there is no connection, neither to 1, 2, or 3. Why? Because this user 3 is offline. If you are offline, how would you have a connection? You will not have any connection. Common sense, right? So you can only be connected to a WebSocket handler once and only if you come online. Is this part clear to all? If you are online, there is no connection. Is this part clear? Okay. If this part is clear, now we move to the next part. What is the next part? One WebSocket handler knows that which user I'm connected to and how many users I have connected to. So this information will be stored. That is fine. But how do I know that U1 is connected to WSH1, U2 is connected with WSH2, U3 is connected with whatever it is connected with, or even if it is not connected with? Who is storing that information, that which WebSocket handler contains which user information? Online means the internet data. Yeah, I mean, any kind of, it can be mobile data, it can be Wi-Fi, it can be Ethernet. That internet should be on. That's what online means. Okay. Now the question comes, WebSocket handler 1, WebSocket handler 2, or WebSocket handler 3, or whatever, thousands of WebSocket handlers I have. These thousands of WebSocket handlers, they are connected to which user? I need to store that information. Why do I need to store the information? First thing, if I'm sending a message, let's say M1 from user 1 to user 2, first thing is that I should know which WebSocket handler it is connected to, because this will be giving the message to it, whatever M1 it is here. This will be giving the message to it. Okay. From the entire flow, which we are going to explore now. But if I don't know that is connected to WebSocket handler 2, I will never be able to send the message, right? So I need to know whoever is going to be my sender, whoever is going to be my receiver, which particular WebSocket handlers they are connected to. Number one. Number two, even if I'm doing in a group chat, I also need to connect in a group chat. Why? In one WhatsApp group, you can have people from anywhere. Agree? WhatsApp group does not mean people has to be from the same city or same country. People can join from different parts of the world. If people are joining from different parts of the world, they are definitely going to have different WebSocket handlers, because we just discussed they are distributed across the globe. So let's say this user one is from India and it is connected to WebSocket ID 112. Just an example I'm saying. This user 2 is from US. It is connected to WebSocket handler ID, which is 911. Okay. All these WebSocket handlers, I need to have information which user is connected to which WebSocket handler. So when I send a message in the group, it is given to all, or it is delivered to all, means I need to be connected with all WebSocket handlers. I need to have this information. Okay. If the WhatsApp is not an open state in a mobile, it still have active connection with WebSocket. It's a very nice question. I'll answer that in the last in service. But before I move there, one moment, before I move there, is this part clear? Why do I need this information? I'll come to all the questions. Why do I need this information, that which user is connected to which WebSocket handler? Is this part clear? Is this part clear? Which user is connected to which WebSocket handler? I need to store this information somewhere. Is everybody clear with that? Okay. And they can change dynamically also. It's not a complete static thing that user one is connected to WebSocket handler 1. It means entire lifetime it will connected to WebSocket 1. They can change also. Any reason, WebSocket handler 1 fails, or user 1 has moved to a different geolocation, or anything else. So they can change also. So means I need to keep them updating. It's not the static data that I'm storing. Okay. Now let me answer your questions one by one and also ask some questions. It's a very good question somebody asked, and everybody who has used WhatsApp, one point in their life, they would have asked this question to themselves, or at least they will be curious about it. I'll cover that in Sublime Text. One moment. Websocket handlers I have explained. I'll go to the next part, but before that, let's see discussion of that. I was going to cover it in last scene, but somebody asked it, so let me cover it. There's something called as last scene. Okay. If you have the read receipts on, only in that case you will be able to see. That's also one thing. Read receipts on and last scene on, both are given the options. So you will see a user last scene on, let's say, sometime, let's say 10:15 a.m. Okay. Now tell me one thing. What does this last scene actually means? Last scene means I'm giving you two options. Number one, user was connected to Wi-Fi or any kind of internet. I'm not saying Wi-Fi. That is when you say last scene, or user opened the WhatsApp. That is when it is last scene. Just give me answer one or two along with whatever your justification. Question is clear? When you say somebody was last seen, is it that their mobile data is on or whatever, internet, Wi-Fi, mobile data is on? Or is just that they opened WhatsApp on that time? User opened when there is active connection. So yeah, just answer one or two, that's it. I mean, when they opened the WhatsApp, obviously being connected on my internet. Both not, it should when a chat open. It should when chat open. Okay. Let's explain that scenario also. Let's say number 3. I have 10 messages from 10 different people, or let's say 100 messages, whatever. 10 messages from 10 people. Okay. Now I open chat from one. So one person will see last seen as one person will see online, and 9 people will see last seen on whatever this point. Is that what you're recommending? Is that what you mean when you say should be when chat open? Because I will not be opening all the chats at once, right? I'll be opening one chat only once. So the moment I open one chat, will it show me online to one user? And for rest of the user, I'll be 10:15 a.m. only. Is that the case? Okay. So what is the answer? 1, 2, or 3? All people will see online, but one person will see last seen. All people will see online, but one person will see last seen. How is that possible? I mean, either you consider this case or you cover the reverse case also. Means 9 people are seeing 10:15. 9 people are seeing online and one person is seeing last seen. Is that practically possible? And even if it is, why would you make it? All right. That also, just to give an answer, the correct answer is number 2. When a user opens the WhatsApp, that is when your last seen is updated. Okay. Repeating it again. I can be connected to Wi-Fi. My phone will always be connected to Wi-Fi 24/7. But I didn't open WhatsApp in the entire day. It showed me last seen was yesterday. Okay. The moment I open the WhatsApp application and I do any kind of thing. So there are two kind of events. One is the app event, one is the user event. User event means anything I do. I go to chat, I open the chat, don't open the chat, I open some profile picture, I check my profile picture, I see the status, or even if I don't do anything, I just scrolled it. Anything, any kind of user event. That is when my last seen will be updated. Okay. It has nothing to do whether my phone is connected to not, if I have opened or not. So only when I open the WhatsApp, that is when your last seen is updated. Okay. Irrespective that you have been always connected to Wi-Fi or any of the internet source. Number 2 is the correct answer. Okay. Just to give an update here. Why did I cover it here? I was going to cover it in last seen service, which is the last part. Somebody asked me, so I have just covered it. I forgot what was the question. The question was, if the WhatsApp is not in open state in our mobile, it will stay active connection with WebSocket. The answer is yes. Irrespective if you have opened it, last seen is different and WhatsApp connection is different. WhatsApp connection is made from the client side. The connection with the WebSocket handler is made from the client side. A user has nothing to do with it. User events are different, app events are different. Making a connection from the WebSocket handlers, it is an app event. It's not something you control. It's the WhatsApp application making connection, not you. Okay. So last scene will not be affected by that. Last scene is affected by the app. Is last scene affected by the user event, not the app event. Access to a particular user is persisted. If the user's internet is abruptly cut, then it is timed out from the server side. Definitely it is. That's why the time to live is very, very small. It is in few milliseconds. Port number to which user is connected to WebSocket handler also needs to be stored. It is, but we are not going into that depth, just to be clear. All right. We have explained this. Now let's move to the next part. I've already explained what is the WebSocket handler, what is the purpose of WebSocket handler. Now we also talked about one important use case is that we need to store information. I'm just writing it here. We need to store information about which user we need to store information about which user is connected to which WebSocket handler. That information needs to be stored somewhere, right? Part number one. Part number two, this information is dynamic in nature. What do you mean by dynamic in nature? Dynamic in nature means WebSocket handler connection can be changed for users. Okay, this. Yes, my WebSockets are spread across geographically, correct. WebSocket handlers means WebSocket handler servers we're talking about. That I've already explained when I was writing it here. Somewhere, yeah, they'll be across different geolocations. Who does this task? Obviously, my WebSocket handler I told you about, it's a lightweight server, means I'm not going to store that information in my WebSocket handler. Repeating, a WebSocket handler is not going to store the information. Which WebSockets are connected to which users? I cannot store that information in my WebSocket handlers. Why? These are lightweight servers. You make a TCP connection request, they respond with the response. That's it. Yes or no, whether successful connection or a failure connection, that's it. Okay. This information is stored in WebSocket Manager. This is stored in WebSocket Manager. If you have to analyze or visualize WebSocket Manager, it is something like this. Like user ID, WebSocket handler ID, and port number and many other details. So something like this. This is maintaining that this user ID, let's say 1010 something, is connected with this port number is 65 and vice versa. I'll just put it to, I'll put it to some other code. Okay. Is that a dedicated service only this purpose? Yes. And this server is very, very important because too many calls go through this server. Why? We are going to discuss that. Okay. Now I'm going to explain what does a WebSocket work manager does and what is the purpose. Also, why there's need of Redis, why it sits on the top of a Redis, all of these things we'll mention about. Here also we'll mention about Cassandra, and then understanding the entire flow will become very easy. So a WebSocket handler, not manager, handler, it will be connected to WebSocket manager. Why it needs to be connected? Why it needs to be connected? As I know, app will do WebSocket handshake with backend servers. It happened in some interval. App will do WebSocket handshake with backend server. Let's call it WhatsApp server. It happened in some interval. Yes, it happens in some interval. It goes via long polling. We'll talk about all that. Why does long polling happens here? Anyways, my WebSocket handler will be connected to WebSocket manager. Why? If there are new users who are added to it. Why? Every time a user can become active or non-active. The moment you turn online, you are active. The moment you turn offline, you are inactive. So which users are active, which users are non-active, that keeps on changing very dynamically. Anybody can go online anytime, anybody can go offline anytime. You cannot stop the users, right? It's their application. So that information keeps on changing every time, and that needs to be updated to WebSocket Manager. For example, user one was active, it was connected to WSH1. Now user one goes offline. So user one is not there anymore. Who needs to update that? WSH1 will update the WebSocket Manager that, hey, user one has gone offline, or let's say 10,000 users have gone offline. I had total 1 lakh users, 10,000 has gone offline. Now I am pending with these many users. That's it. So a WebSocket handler will be connected to the WebSocket Manager, who will do what? Which is just a repository of information. I'm just putting third here about which user is connected to which WebSocket. That's it. Which user is connected to which WebSocket handler? That is what this WebSocket manager stores, nothing else. Okay. Fourth point, important. It sits on the top of what? On the top of Redis. Why it sits on the top of Redis? Because it stores two types of information. What is that? Number one, which user is connected to which WebSocket handler? And number two, what all users are connected to a WebSocket handler? Both informations are stored. First, which users are connected to which WebSocket handler? That is going to be 1:1 connection. And what all users connected to WebSocket 1, which is 1:1 connection, that is going to be stored at all. Okay. What happens in a case when a connection breaks? When a connection, how would WhatsApp server know if connection with user is broken or user went offline? That's what I'm explaining. Your client side means your mobile device or laptop or whatever it is always making connection with the WhatsApp server. How does that connection work? That connections once via long polling, right? So your device, whatever that, I'm just calling it device, your device and your WhatsApp server, they are always in a long polling. So it's always requesting for new messages. If there are new messages, it will update and vice versa. The moment that connection breaks, it's just a long polling connection. The moment it breaks, it will be break, right? The moment that connection breaks, it will be updated that the user has gone offline. Okay. So when a connection between a user and a WebSocket handler breaks, okay, and they connect to a new WebSocket handler. So this information is updated in Redis via whom? WebSocket Manager. This part clear? Let's understand this part again, the WebSocket Manager, then I'll go to the message service. But if user went offline, how WebSocket Handler would know it? Because WebSocket Handler is the one making connection with the user. That's how. Okay, understand this again. The moment connection break, user is offline. Whatever happens is the alternative. Maybe the user didn't went offline, the internet was disconnected, whatever. The moment WebSocket handler breaks the connection, the user went offline. That's it, not the other way around. Okay. If it gets connected with a new WebSocket handler, that will be updated in the WebSocket manager. That is a different part. Okay. So let me explain this portion of the bit here. Then we'll go for messaging service and all. And slowly, we are there in the communication part. So just means WebSocket handler is unique per user. No. It does not need to be unique per user. I told you it can handle 60,000 users, right? Okay. Now let's talk about it here. User one connected to WebSocket handler one. How does that connection happen? That connection happens whenever it's connected to any internet active device. Okay. The moment internet connection comes, it's connected to WebSocket Handler once. This information is stored in WebSocket Manager, right? So WebSocket Manager, as the name suggests, it stores two kinds of information. U1 is connected to WSH1 and WSH1 is connected to who all users. One WebSocket handler can make active connection of 60,000. So not just U1, there are 60,000 users who are connected to WSH1. Who are these 60,000 users? Number one, that is stored in a list, those user IDs. They're stored in a list in WebSocket Manager, part number one. Part number two, U1 is connected to WebSocket Handler 1, that is also stored there. 1:1 connection, N:1 connection, both are stored there. Okay. Similarly, U2 is connected to this, U3 is connected to whoever, all of this is information is stored there. Only active user connection. So U3 is not stored anywhere. U3 will not be in my WebSocket Manager. Okay. The moment U3 will come online means will be connected to any internet active access. In that case, it will be in my WebSocket Manager. Only the active users are there in my WebSocket Manager. Okay. Part one. Why did we put a Redis on top of it? And not just Redis, we put 3 clusters of Redis. There's a difference between putting just one Redis and 3 clusters of Redis. Why did you put 3 clusters of Redis? Why? Because first of all, this is too much information. How which many users? We have billions of users already, and they're connected to different WebSocket handlers, port numbers, etc., right? That is too much information. And we cannot just query in the server all the time. WebSocket Manager is a server. You cannot query the server all the time for this information. And that is the reason we use cache. That is why we have a cluster of cache here, which we call as Redis. We're using Redis cluster here because I can quickly check in my WebSocket Manager. Okay. It's always going to be in sync. That time to live is going to be very short because I need to quickly check it because user come online, user come offline, and so on and so forth. Okay. Now, about the case which I mentioned in the last line is that when a user goes offline or connection breaks for any reason, connection between, let's say, U2 and WebSocket Handler 2 breaks because user 2 goes offline. The moment user 2 goes offline, WebSocket Handler 2 says that, hey, user 2 has gone offline, update in the WebSocket Manager. Remind you again, this is my server, or don't call it database, just call it server at the moment. And from server, you are having the caches on top of it. Redis does not know it. Redis does not know that U2 has gone offline. So Redis needs to be in sync with the WebSocket Manager, then it will update in the Redis and vice versa. Okay. Simple cache validation and validation thing. Okay. If I understand correct, user has only one WSH for lifetime. No, that is incorrect. That's what I said. One user can be connected. Yes, one user can be connected with only WebSocket handler at one point. It cannot be connected with both WebSocket handlers at one point. That is incorrect. One WebSocket handlers at one point, that is correct, but does not need to be for lifetime. Does not need to be for lifetime. Okay. The two possible scenarios, one moment. The two possible scenarios I'm giving you. First thing is that, let's say you India, or forget about India, even when you change cities, your WebSocket handler changes. But I'm taking this bigger example. You're currently in India, you move to Singapore, right? Obviously, you are connected to some other WebSocket handler when you were in India. Now you're connected with other WebSocket handler when you're in different location. So one possible case is user change the location. In that case, WebSocket handler location will change, no doubt. Other possible case is that connection breaks for some reason. So user 1 is not able to connect to WebSocket Handler 1 for whatever reason it is. Either WebSocket Handler 1 is down or it is at the limit, it's not working, any reason. In that case, that does not mean your WhatsApp will not work. Your WhatsApp will still work. It will find the next WebSocket Handler, it will connect you there. Just because this connection is not being successful for any reason, then it will just cross this and will connect here. But at one moment, you will be connected with one WebSocket Handler. That's it. This load balancer guarantee once user connects to one server, but continue to use same. In general, load balancer no guarantee to which server request forwarded. No. The whole purpose of load balance is to distribute the load, nothing else. If WebSocket handler call to manager gets failed to inform disconnection info, connection with U2 will still show active and Redis. That is correct. That is correct. If this connection fails, it is not able to update, then in Redis, it will not be updated. That is all correct. Cache invalidation case. Okay. And that is why they are sequential calls. So first it is updated in the WebSocket manager, then it updated in the cache. It's not parallel calls here. This part clear to all? Two things we have covered, and to be very precise, just one more thing is pending and your communication part will be done. Two things we have cleared is that every device needs to be connected with some WebSocket handler, one at a time. Okay. Who is maintaining these records? These records are maintained in the WebSocket manager. And that WebSocket manager contains Redis on the top of it, so we can have a quick lookup time. This part clear to all? I'm highlighting this part, whatever we have discussed in the design diagram so far. We discussed this part so far. Anybody has any doubt, let me know. If this part is clear, quickly type clear, then we are going to talk next part. All clear with this part? WebSocket Manager, WebSocket Handlers, and this. Explain load balancer in between WebSocket Handler and WebSocket Manager. Guys, too many different questions. Let's stick to the topic and then we'll answer. Load balancer in between WebSocket Handlers and WebSocket Manager. Okay. I told you a daily active users here 1 billion and one WebSocket handler is 60,000. So even if you do a rough calculation, there are going to be millions of WebSocket handlers. That is why to handle scale from these millions of WebSocket handlers and between this WebSocket manager, I created a load balancer in between. Okay. Whole purpose of load balancer is to distribute the load. That's it, nothing else. When you have load of such high traffic of the scale of WhatsApp, that is why you need load balancer in multiple places. Okay. It's exactly as you can think of a 3-tier architecture. I have between tier 1 and tier 2. That's it. Okay. Did you mention functional languages would dominate OOPS languages in near future? Already dominating. Well, technically both statements are correct. They are already dominating and they will dominate. Go is a functional language. It's good to start learning Go. It can't be used in all kinds of apps, right? Definitely it can't be used in all kinds of apps. It's good to start learning Go as long as you are targeting specific companies. Not all companies use Golang. So be very precise in which companies you are targeting. Majority of the companies are shifting to Golang, but majority of have not yet. Okay. So if you have to start learning with the language, my preference would be, or my recommendation would be, not preference, is to start with Java, which is a OOPS language. It will cover your OOPS concept. Then when you will understand the requirement of functional programming, because then you understand the blockers of object-oriented, then you'll understand the functional programming, and then you can switch to a particular tech stack. In terms of overall, Java is still the most commonly used backend language. Okay, Golang is still picking up. All right, this part is what we are done. Cool, guys. This part clear to all? Between U1 and U2 is only to make user connections. When user is connected, there will be no role of load balancer in sending message rate. In sending message, okay, understand this again. Purpose of load balancer is just to distribute the load. That's it, nothing else. Nothing to do in seconding connection or sending messages or anything. Once a connection is set up between U1 and WSH2. No, it will be U1 and WSH1, right? Yeah, whatever it is. U1 and WSH1, load balancer has nothing to do there. Messaging, nothing has to do there. Load balancer is just to distribute the loads. That's it. All right. This part clear to all, guys? Then we have to cover second part of this communication also, and then it will cover. Okay. Cool. Apart from that, so this part we are clear with WebSocket Handlers, WebSocket Manager, Redis cluster. This part we are clear with. There is one more thing which happens. This WebSocket Handler, it has a connection, active connection with WebSocket Manager all the time because it keeps on updating whenever there is a people who have gone offline, people who have come online, right? New users can be added to it or some existing users can be deleted from it. So it is always making a direct connection with WebSocket Manager. This is, let's call it connection number 1. But every WebSocket handlers has one more connection, and that connection is with messaging service. Let's call this connection number 2. These connections are parallel. They are not sequential connections. Repeating again, these connections are parallel. They are not sequential connection. Means every WebSocket handler, it is connected with a WebSocket manager and it is connected with a messaging service all the time. Now the question comes, it is connected to a WebSocket manager, makes sense. Why? Because at every moment, some users might be added, some user might be deleted. It need to update to WebSocket manager, so their connection makes sense. Why a WebSocket handler? I'm not talking about manager, I'm talking about handler. Why does a WebSocket handler needs to make a connection with the messaging service? That is something which you're going to answer now. To Sublime Text, let's answer this here. So here we talked about WebSocket Manager. Now we are going to talk about messaging service. Okay. What is messaging service? Why do we have a connection here? Let's talk about that. Number 1, a WebSocket handler, not manager, handler. While talking to WebSocket manager, will also in parallel talk to messaging service. Okay. What is messaging service? As the name says, messaging service is the repository or combination of all messages in the system. So when we say we are going to store the messages in the database, that is what this messaging service does. That you have to persist temporarily till you get the read receipt back. That needs to be stored somewhere. That is stored in your via your messaging service. Where? In Cassandra. Repository of all messages in the system. On top of it, there are existing APIs. Okay. So I'll just put it here. It will expose APIs to get messages by various filters, like message based upon, I'll show you, get call based upon user ID, another get call based upon message ID, user ID, message ID, or anything else that you want to. For example, group ID, delivery status, all of this, etc. All of this is built, all of this is exposed at the messaging service. Okay. Now comes the question, where are these stored? Sorry guys, my connection is stopped. So where are they stored? This connection, this service sits on top of Cassandra. Why Cassandra? Why not some other database? That discussion also we can have. Okay. What is going to happen here is any kind of message which will be stored, it will go via messaging service and is stored in the Cassandra. Now we are in a good shape that we can update how does the communication happens. Now I'm going to explain the entire flow. Please pay attention here, and that is when we'll cover this. I'm talking about two scenarios, scenario number 1 and scenario number 2. Scenario number 1 is that both users are online. My sender is online, my receiver is online. Of course, my sender needs to be online to send message, right? Now what happens is U1 is sending a message called M1 to the user. U1 is sending a message called M1 to user U2. Repeating you, both are online. Okay. U1 is connected to WebSocket Handler 1, U2 is connected to WebSocket Handler 2. What will happen? You will send a message with message ID M1, it will go to WebSocket Handler 1. The very first thing is that WebSocket Handler 1 makes two parallel connections. One with the WebSocket manager, which I called as connection 1, and one with the messaging service, which I called as connection 2. WebSocket Handler 1 will tell that, hey, I have a message for user 2. You tell me which WebSocket handler contains user 2. That is what WSH1 will ask. Okay. In second connection, it will say that, hey, I have a message M1. Please store that message M1 in the Cassandra. So it will store in the Cassandra. That's it. Until now, everybody clear? Until now, everybody clear? Scenario number 1, when both of them are online, sender as well as receiver. Come on, guys, be quick. Until now, everybody clear? Okay. They're not atomic operations. What do you mean by atomic? You mean sequential? No, they're parallel calls. Okay. Now what will happen? There's a race condition which will happen also. We'll talk about it a bit later. But anyways, this is something that will happen. Now it will look up. It will say that, hey, the user that you want to send the message or who is going to be the receiver for this message resides in WebSocket Handler 2. It will say WebSocket Handler 2 is something which you should connect with. So WebSocket Handler 1 will connect with WebSocket Handler 2. It will say that, hey, I have a message for you, right? Now what will happen? WebSocket Handler 2, it will look up in the message service. It will ask, hey, do you have any message for my user? Do you have any message for user 2? Message server will reply, yes, I have a message for you. and it will send M1 to the U2. Now M1 will be delivered to the U2. The moment M1 is delivered to the U2, it will send acknowledgement. It will say, hey, I've successfully received the message. The moment it send acknowledgement to WebSocket Handler 2, it will be updated in it has direct connection with messaging service anyways. So it will have connection with messaging service. The moment acknowledgement is received, it will be deleted from the Cassandra. It will be deleted. The message will be deleted from the Cassandra. Okay. And that is how U1 will be updated back. So after this acknowledgement is sent, WebSocket Handler 2 will send the acknowledgement to WebSocket Handler 1. Now there is no need for WebSocket Manager to interpret here. These WebSocket handlers can connect with each other also. That's why you have this communication. Okay. So WebSocket Handler 2 will send acknowledgement to message service. It will delete from Cassandra. WebSocket Handler 2 will send acknowledgement to WebSocket Handler 1. And that WebSocket Handler 1 will send it to U1 that, hey, your message has been successfully delivered. Not seen, delivered. Okay. So U1 will see what? As of now, it will see a single tick. After this acknowledgement, it will see a double tick. Okay. And once they have seen the message, then they will see the blue tick. So that's it. This part, scenario number 1, when both of them are online, sender as well as receiver, is it clear to all? Is this part clear to all? Sender and receiver both are online. Why there is need for WebSocket Handler to connect to each other when they can communicate through WebSocket Manager? Good question. First thing is that these are lightweight servers. They're going to connect very quickly as compared to going every time to WebSocket managers and then connecting to messaging service and vice versa. They already have connection with WebSocket Manager and messaging service. All WebSocket handlers have connections open with them. Connection across lightweight servers are much faster as compared between connection across lightweight and a heavyweight server. That's why. Okay. Cool. This scenario is scenario number 1 when both of them are online. I'm just going to note it down. And then we'll go to scenario number 2 when, let's say, this user is offline. That is scenario number 2. So I'll clear everything. And then we'll go back. This, I'll get chat here. WSM and message service are also, yes, everything will be geographically distributed. If users are geographically distributed, respective services will also be geographically distributed. As simple as that. Okay. Now this service sits on top of Cassandra. Now, I told you about, we can have a discussion why we chose Cassandra here. The people who have used Cassandra or those who have not even used Cassandra, when we talked about the initial list of databases, I told you one thing about Cassandra. That is, it's called ever-growing database. Means you have to store a large amount of data, very large amount of data. I'm talking about millions, not even millions, billions of events or billions of messages. That is where you go for Cassandra. Why? It is very easy horizontally scalable, very, very easily horizontally scalable. Your one server is up, get another server, get another server, get another server. Whatever number of resources you can get, it is very easily scalable. Okay. Neither S3 is that much easily scalable, neither DynamoDB is that much scalable, Azure or any of the GCP, whatever you can think of, is that much easily scalable. Okay. So coming back to Cassandra, we expect that new users will keep on getting added. Okay. And we will have new conversations every day. Means what? It's a ever increasing data. And whenever you have ever increasing data, whatever system you are designing, wherever a use case, we have to store large amount of ever increasing data. That is the perfect use case of Cassandra. Okay. That is why I've used Cassandra here, right? I think WhatsApp recently upgraded to Cassandra, isn't it? Recently means what? Well, technically, WhatsApp doesn't use Cassandra. I will not reveal what they use because it's an internal database. They don't use Cassandra, they use alternative of Cassandra. So anything that you know in public means whatever is open source, Facebook has its own version. Facebook doesn't use AWS, GCP or anything or S3. They use certain services. I'm not saying it doesn't use S3 at all. It uses certain services, but WhatsApp has its alternative. Everything is internally built at Facebook. They have their own private cloud also. They are not dependent on AWS, GCP or anything. They have their own private cloud. They have their own streaming services. They're not dependent on Apache or streaming or Hadoop or anything. Everything that you think is open source out there, they have their internally built. And all major companies have it. It's not just Facebook. Netflix also use the same. Netflix have their own CDN as well. So all of these companies, they make their own internal tools as well. Okay. So this service sits on top of Cassandra. Best database or best use case for that is Cassandra. Okay. Now, what else do we need? We also need just one more thing to add. Also, we need to run finite number of queries that on messaging service based upon various filters. Netflix uses AWS for cloud hosting, isn't it? Yeah, actually used for cloud hosting. I'm not saying everything they are going to use on their internal tool. It depends on your CapEx and OpEx as well. Capital expenses and operating expenses, right? It's much easier to use something which is out there in the market internally, right? So that effort that needs to be analyzed. So they use AWS, they use other tools as well, or whatever open source is there. In addition to that, they also use something which is internally built. So CDN, they are not dependent upon, I think it was called CloudFix or something, which they were usually initializing, OpenDNS and CloudFix. After that, we have stopped using, they made their own CDN because they gained a lot of money from it. I mean, they were saving a lot of money from it, to be very precise. Okay. It's not worthy to make a cloud hosting service if you already have AWS. That's why majority of the companies don't make it. But companies who have the money, they prefer keeping their own private cloud. And not just own private cloud for all the use cases. Only for very sensitive information, they use the private cloud. That part. Okay. Majority of the cybersecurity companies, they have their own private clouds. Any cybersecurity company you can take, for example, okay, including Cisco, including OpenDNS and OpenSSL and many other companies. Okay. Gartner as well. Now, we need to run finite number of queries on messaging service based upon various filters. The filters we talked about: user ID, message ID, etc. User ID, message ID, etc. Okay. For these use cases, we fit the Cassandra. So I just listed down here, those 4 and 5. Okay. Now, one thing to be very clear is that messaging service we talked about. Could explain a scenario when user A comes on and how does everyone else gets the status as user A online? We see a little online text below name. How does status gets published? That we'll talk about in the last scene service. That is the last part of this. Let's understand how the communication works. Then we'll go for asset service communication. So that is the last part. That's I'm not even much concerned about. Okay. To give a simple answer, it's an event which is triggered. And that event says the user is online. That's it. You will open WhatsApp application. Anything you do, you click a single button, you scroll, you go to a chat, you read a chat, you see a status, you read a status, even you open your own profile picture or open anybody else's profile picture, everything will be tracked. And tracked in the sense there's an event generated, right? That event generation says the user is online. That's it. Okay. This messaging service, I'm adding a note here as well. At this point, you should be very clear. Either you're designing a Facebook Messenger or you're designing WhatsApp. Okay. Does database need to store messages forever? This is something you need to make clear choice. Okay. In Facebook Messenger, ideally this should be here. In Facebook Messenger, yes. In WhatsApp, no. They are deleted after the acknowledgement. They're deleted after the acknowledgement. Okay. So when you're making a system, you should be very clear which database to use. Here in WhatsApp, I'm deleting it, but in FE Messenger, you don't have to delete it. So you choose a database which is ever increasing and you don't have to delete anything. Okay. This part. Now coming back to our conversation, which is U1 to U2, that is scenario number 1. Scenario 1, both sender and receiver are online. What happens in that case, right? So I told you about user 1 connected with WSH1, user 2 connected with WSH2. If they're connected, common sense, they're online, right? How else they would have connection? User 1 wants to send a message M1. Let's say message ID is M1. Message is just a simple hey, and wants to send to user 2. How does this flow will look like? Let's have a look. Okay. When U1 decides to send a message to U2, the first thing which will happen is it communicates this to WSH1. The device from the U1 will say that, hey, WSH1, I want to send a message, this whatever message ID to user 2. Now what will happen, right? The moment it communicate to WSH1, WSH1 will communicate to whom? Will then talk to WebSocket manager. It will say to WebSocket manager that, hey, WebSocket manager, I want to send this message to U2. You tell me which user, you tell me which WebSocket handler U2 is connected to. To find out which WebSocket handler is U2 connected to. Okay. And obviously WebSocket handler and the WebSocket manager will respond with WSH2. Okay. So WebSocket manager will tell WSH1 that, hey, the user that you want to send message to, it is connected with WSH2. As simple as that. Is this part clear to all? Is this part clear? We have already discussed. I'm just documenting it. Now what will happen? There are going to be parallel calls. WSH1 will make a parallel call to whom? Messaging service, right? Which will save the message M1 into what? Cassandra. And then what? WSH1 will be connected to WSH2. After that, what will happen? If both users are online, what is the need of saving message on Cassandra? Okay. Let's understand the purpose again. Why are we saving the messages here? Irrespective users are online or users are offline, you need to have an acknowledgement that a message is delivered. Let's say even the users are online. What is the 100% guarantee that the message will be delivered? There's no guarantee, right? That is why you're persisting it here. Even if the users are online, you send the message, you receive the acknowledgement that a send message has been received, then you delete it from the database. That is why there's a need to have a database at all. Okay. All right. So WSH1 will make a parallel call to messaging service, which will save the message M1 into Cassandra, and WSH will be connected to W2. Okay. Now what is going to happen? WSH will be making a call to W2. Is that M1, once M1 is delivered to U2, WSH2 will send acknowledgement. Okay. Acknowledgement to messaging service. And then message M1 will be deleted from Cassandra. Is this part clear? The moment you have received the acknowledgement, then it will be deleted from the Cassandra. Okay. Guys, this part clear to all? Okay. After receiving acknowledgement, one moment. After receiving acknowledgement, then what will happen? WSH1. Will WSH1 deliver the message? No, messaging service communicate with Cassandra. No WebSocket handler directly communicate with Cassandra. Only they communicate with messaging service. So messaging service will update the Cassandra. Okay. So WSH1 deliver the message or messaging service from Cassandra. Deliver the message means what? Acknowledgement message you are saying, or you're talking about some other message? Okay, I'll explain the flow again. Means from where receiver will receive the message. That comes from messaging service only. After same acknowledgement, WSH2 will update WSH1 and WSH1 will update U1. That message has been delivered or seen, whatever it is. Double tick or blue tick. Okay. This is the entire flow. Now let me just show you this again. One moment, let me cover this flow again and then we'll connect back. All right. Simple use case scenario number 1. User 1 sends a message, hey, to user 2. Both are online, both are connected to different WebSocket handlers, as simple as that. Okay. Now, what is going to happen here is this WebSocket handler 1, it will say to WebSocket handler 1 that, hey, I want to send a message to you 2. So WebSocket handler 1 will say, okay, I'll connect with WebSocket manager. I will try to identify which WebSocket handler it is connected to. So it will have a lookup in the WebSocket manager, and parallel it will make a call to messaging service that, hey, this message, hey, needs to be sent. So it will store in the Cassandra. That's it. Now what will happen is WebSocket manager will reply that, hey, the user that you're trying to send message, it contains in WebSocket handler 2. So WebSocket handler 1 will make connection with WebSocket handler 2. It will update that, hey, I want to send you some message. Okay. So WebSocket handler 2 will look up for this message in U2. It will look up from the messaging service. It will get to know that some message, hey, is there for user 2. So it will update the user 2 that, hey, there's a message for you. And user 2, after receiving the message, will send an acknowledgement. After receiving this acknowledgement, WebSocket Handler 2 will update the messaging service that I've received this message from the Cassandra. It will delete the message from the Cassandra. Okay. Also, it will update WebSocket Handler 1 that, hey, I've successfully received the message. So you can update your sender that it has been delivered. Double tick. That is the entire flow which goes end to end when both the sender and receiver are online. Okay. Now let me just check it here. Why WSH1 is connecting to WSH2? Once message is sent to messaging service, should be sent by WSH2 by connecting to messaging service. I told you the connection between two lightweight servers is much quicker as compared between lightweight and heavyweight servers. That is the reason we are connecting WSH services. After sending message to WSH2, will it check for online status? Before sending message to WSH2, will it check for online status? No. I mean, who will check for online status? U1 you are saying or WSH1 you are saying? When you send a message, you don't check if the WebSocket handler cannot check it, right? WebSocket handler 1 cannot check if user 2 is online or offline. It's not its task. Only it can check for your users. So technically your question is, when you send a message, do you check if the people are online? You don't. I mean, you might or you might not, but generally speaking, you don't. If you have to send a message, you send a message. Whenever they will come online, they will see it. That's their task. WSH1 can never check if U2 is online or offline. It can only check or only get to know that it is connected to U in WSH2. Whether it is not connected or connected, that is given by WSH2. That's it. Okay. All right. This part clear to all? So it's a pull based if user comes from offline. Yeah, on offline case we're going to discuss, but the online case I've covered as of now. Is this part clear? Come on, guys, everybody else. Okay, cool. Now we'll talk about the scenario number 2. Let me just go to this part. This is scenario number 1. And now I'm talking about scenario number 2. Obviously, sender has to be online and receiver is offline. What will you do in that case? You're sending a message to someone, but the receiver of that message is offline, is not available basically. What happens in that case? Let's have a look quickly. Okay. Same flow, entirely same flow will happen. Just one thing will change. Let's see. This time, U1 wants to send a message, let's say M2, or let's call it M3 to user U3. Obviously, this is the sender. This has to be online, but now it wants to send a message M3 to U3. This is the expectation. U3 is offline. Okay. So U1 will say to WebSocket Handler 1 that, hey, I want to send a message M3 to user 3. WebSocket Handler 1 will say, okay, I will check with the WebSocket manager. I'll ask it which WebSocket handler U3 is connected to. And parallelly, I will go to the messaging service. I will update that there is a message M3 for user 3. It needs to be updated in the Cassandra. Until now, everybody clear? Until now, everybody clear? Okay. Now you guys tell me, what will WebSocket manager reply here? WSH1 asked, which WebSocket handler is U3 connected to? What will WebSocket manager reply here? Correct. The answer is null or no connection because U3 is not connected with anyone. So this flow ends here. At this moment, this flow will end here. So that is the reason at this moment, U1 will see a single tick. This part clear? Single tick means it is sent from its end. It is stored in the database somewhere. It is sent from its end, but the person that you want to send to is not online. So it will be only a single tick. It will not see a double tick. All good? Okay. Now what will happen? If U3 doesn't come online, definitely it will always remain a single tick. It will never become a double tick, right? And that is persisted for 30 days. Now what will happen? Now U3 comes online. The moment U3 will come online, it will make a connection with, let's say, WSH3. Anytime any device will come online, it will make a connection with WebSocket Handler. So U3 comes online, U3 makes a connection with WebSocket Handler 3. The first thing WebSocket Handler 3 is going to do is, again, two connection. Parallel connection, one is with the WebSocket manager, one is with the messaging service. So I'm going to clear this so I can explain it here again. It will make a connection to WebSocket manager. It will say that, hey, now U3 is connected with me. It will update the WebSocket manager. Second connection is messaging service. It will ask that, hey, do you have any messages for me? Do you have any messages which is targeted for my user, U3? Now the messaging service will reply, yes, I have a message. That message ID is M2. Then the messaging service will give it to WebSocket Handler 3. It will go to here. And at this moment, when it goes for M2, it will be delivered to M3. It will send back an acknowledgement in the same previous discussed flow. After receiving this acknowledgement, this message will be deleted from Cassandra. WebSocket Handler 3 will update WebSocket Handler 1 that, hey, I have successfully received. And that is when that single tick will become a double tick. All clear? Easy. Online flow, offline flow, both we discussed. So let me clear this part too. And just write it down quickly. Okay. I'm going to cover like this only. I'm just going to edit it. So it's going to be easy. This double gray tick or double blue tick? Double gray tick. Delivered is double gray tick. Blue tick is only once it is seen. Okay. So WSH1 wants to send M2, sorry, let's put it M3, which is hi, to U3. U3 is connected to what? U3 is not connected to anything. It is offline. Means not connected to any WebSocket handler. So this will remain the same when user is connected to, it will ask which is connected to WebSocket will respond with null, means no active connection. Then what will happen? We'll make a parallel call. It will save the message M3 into Cassandra, and that's it. It will not connect with WSH2 at this moment. Then what will happen? After this, when U3 will come online, and make connection with WSH3. At this moment, when U3 will come online and make a connection with WSH3, WSH3 will make parallel call with whom? With WebSocket Manager and the messaging service. Now what will happen? WSH3 will ask if there are any new messages for U3 or anything in the WSH3 from messaging service. Messaging service will respond with what? M3. And once M3 is delivered to U3, WSH3 will send acknowledgement to message service. Then the message M3 will be deleted from the Cassandra. After resolving this acknowledgement, WSH3 will also update WSH1 and WSH1 will update U1 that message has been delivered or seen. That's it. Rest of the flow is same as it is. Everybody is clear with scenario number 1 and scenario number 2. Just let me know in the chat. Everybody clear with scenario number 1? If receiver comes online, sender goes offline, how will the message acknowledgement be sent to sender? Good question. If receiver comes online, it is delivered, obviously it will be deleted from the database. No doubt about it. Message will be deleted from the database. But if the sender goes offline, they will not be updated. In that case, it will be updated in the WebSocket handler that, hey, my message or my acknowledgement has not been sent. So till the moment your WebSocket handler actually comes online or the user one sender comes online, it will send your connection request or WSH3 will connect with WSH1. But till then, it will be stored in the WebSocket manager. Okay. Cool. This part clear, guys? We can go to next part, which is local caching and then group messaging service. Okay. If this is clear, then I'll go to next part, which is we can continue here on. Local caching. What is the meaning of local caching? Anybody? Caches in servers, server level. Okay. Then why do we call it local if it is server level? What's the difference between caching and local caching? That was my question. Is whenever you're talking about local caching, it's common sense. Locally, you're talking about a certain frame of reference. Now, what is that frame of reference? If I'm talking about a device, local caching means caching on device. Caching on server will never be called as local caching. Server can never be a frame of reference. It is already responding something, right? So if I'm using a smartwatch, my smartwatch is my local device. That is the caching there. So caching on smartwatch is local caching. Okay. So what is the meaning of local caching and why it is important for our use case? Let's say, I'm just taking one case. U1 wants to send message to U2 with message ID M2. Okay. Now the scenario is U2 is online. U2 is online, it is connected with WSH2. Correct. Your receiver is online, but your sender is not. So it is not connected to any WebSocket handler. Your sender only itself is offline, your receiver is online. What do you think will happen? Obviously, just because your sender is offline, that doesn't mean you can stop the user from typing the message. Obviously, you cannot send the message, but you cannot stop the user from sending the message, right? In that case, message sent from, it is not sent, but yeah, just write it, from U1 will be stored where? Will be stored in a local database. All your client side also, which includes all your devices, also have their local databases on the device. Okay. As soon as a network connection is there, then what will happen? WebSocket handler will pull all the messages from local database and then what? Send them in the same flow as we discussed. That also one scenario I wanted to talk about. So you might have seen when you're offline and you send a message, you won't see a single tick. Agreed? When you are offline and you send a message, there is no single tick. Only when you're connected with network, online, and then you send message, that is when you see a single tick. I believe this everybody should have tried or at least seen. Is this part clear to all? Is this part clear to all? But that does not mean that you have typed a message and you have to wait till you come online. No, you have typed a message, you have clicked on send. Obviously, it will not be sent because you're offline, right? But when you connect, you don't need to type the same message again. That message will be picked from the local database. It will be sent there and that will be communicated back to you. Okay. That is a local caching. So we have covered all scenario of 1:1. You can call it a scenario 3, but it's not that important, but still you can cover it. One moment. Scenario 3, sender is offline. If U1 sent message not delivered yet, but stored in Cassandra because U3 is offline. One moment. If U1 sent message not delivered yet, but stored in Cassandra because U3 is offline, correct. Now, if U1 decides to delete message, will it be deleted from Cassandra? I have seen like U3 will see the notification like I have deleted. It will be deleted, but only after getting sent. Only after getting sent, it will be deleted. Okay. It's not like you send it a message and before it getting delivered, you delete it, so it will not be updated. No, it will be deleted, no doubt, but after being sent. All right. Where does multimedia messages are stored if sent? They are stored in a S3 bucket, which we are coming. That is in the asset classes. Asset classes we are going to come in. But prior to that, in the communication, 1:1, I have not covered group chats yet. I'm going to cover it now. 1:1, everybody clear? How does communication happens? Both sender, receiver online, receiver offline, sender offline, all scenarios we covered. At all. Okay. If this part is clear, now we are pending with just few of the other things. One of them is most important is, which is 6th number, right? 7. How does group chats work? Very important. And number 8, how does your asset delivery works? Okay, asset delivery is also very important. And then we'll talk about analytics, last seen service, and finally, monitoring and logging. That's it. Okay. Out of this, group chats and asset delivery are important. The rest of the things we can consider. It's fine. But I'll cover everything in detail. Now let's talk about the group chat application. That is important. We have seen how does one-is-to-one chat application works. That is fine. If I have to extend it for a group chat application, how it will work. Okay. So let's say U1 wants to send a message to G1, group number 1. Obviously, validations will happen before sending a message that whether the user is a part of that group, whether the user have access to send message to the group, because in some groups only admins have the access, right? So all of this validation will happen before sending a message, not after sending a message. Common sense, right? Now what will happen is groups behave slightly different from users. So whatever flow that you have seen, the flow would be pretty much similar, but not exactly similar. Something will change. Okay. What will change? We talked about WebSocket handlers. WebSocket handlers can't keep track of groups. Okay. So which user belong to which group and which group contains which user, that track cannot be kept by WebSocket handler. WebSocket handler mostly like which users are connected to me, not like which users they are part of group of, and vice versa. Okay. It just tracks active users. That's it. Okay. Now WebSocket handler is out of the picture. Now what will happen now? So when U1 wants to send a message to G1, in that case, what will happen? My WebSocket handler 1 cannot contain information of the group. So it will get in touch, will talk to whom? It will talk to messaging service. Okay. And messaging service will talk to what? Kafka. U1 will connect with WSH1. It will say that, hey, I want to send with G1. Now, WSH1 cannot store the information of G1, just like it stored the information, it connects with WSH2. It doesn't happen in the case of groups. Groups behave differently from the active users. So WSH1 will say, okay, you want to send the message. I will update in the WebSocket manager. I'll update with the messaging service. Now messaging service will understand this is a group call. So there is no point of checking again in the WebSocket handlers because they can't handle it. So WebSocket handler will communicate with Kafka and will tell that, hey, U1 wants to send a message to G1 in that case. Okay. So what will happen now? Let's say send a message M4. Now M4 will be stored in Kafka with what? With an instruction that it needs to be sent to G1. M4 message will be stored in Kafka with an instruction that it needs to be sent to G1. Now what will happen? At this moment, now Kafka will interact with whom? Kafka will interact with group messaging service. Or group messaging handler, whatever you can call it. Okay. This will send out all the group messages. Okay. And obviously, except for U1, it will send all the messages in the G1. So all group messages to all users in G1 except U1. So that is why whenever you send a message in group, you don't receive it. You send it, but you don't receive it. Okay. Now, it keeps track of group service, keeps track of all members in all groups. So same task which was performed by WebSocket manager is performed by a group service. Same as WebSocket manager in 1:1 chats. Same task be performed by the group service there. Okay. Now what will happen? My group messaging service will connect with group service and then do what? To find all the users in G1 and then follow the same process. Socket handler and then deliver the message to all users individually. So the only difference is between the communication which happens between Kafka and groups of messaging service, which you don't even know. At the end of the day, whether it is coming from one user or it is coming from a group, for your end, it is just going to be a WebSocket handler. It is updated 1:1. Okay. So as an end user, you won't even notice the difference. But the only difference which happens in their communication flow is that the group message goes to the Kafka versus it going to a WebSocket handler. Why? WebSocket Handler, as I told you, it's a lightweight server. We don't want to put any business logic there. For example, which group contains which many members or which members belong to which group. That is not the task of WebSocket Handlers. And also, we're not storing that information in WebSocket Manager. So that is why we need to store another event, which is Kafka. And in Kafka, we are updating those sections. That's it. This part clear to all? Come on, guys. This part clear to all? Okay. Now we are just left with assets delivery, analytics, last seen service, and monitoring and logging. These are important. Will take around 15-20 minutes to cover, but that is what we're going to cover in tomorrow's class because I have another class to rush for and we are already a bit minutes ahead, but that's fine. Okay. But today was a good discussion. We talked about detailed component level design. I will share the diagram with you. Please have a look at it and try to understand each and every component. Two components we have discussed. One component is pending, which is the user seen service and last seen service, which I'm going to discuss tomorrow. Okay. In the meantime, please revise the notes. I'm going to share that in your channel. It will be shared across whoever your platform is, right? Your learning platform. We'll connect tomorrow. We have to start with low level design, but first we'll connect with our WhatsApp system design and then we'll go with our low level design. Some basic recommendations, learn about the very basics of low level design. If you want to start with like the architecture patterns and very basic things, we'll be covering that tomorrow. And then we'll go for the next advanced steps. Okay. Cool, guys. Please revise these notes and revise all of your HLD before we move to the LLD part. Thanks for joining in. Have a good day and we'll connect tomorrow.